Black holes are weird. You know what's even weirder? Time around black holes. For years, everyone believed time was universal. Every second, the same for everyone. Until one day in 1905, some random guy called Einstein was like, hey, maybe time actually changes with motion. I'm gonna call it special relativity. Turns out, he was right. The faster you move, the slower your clock moves compared to someone who's standing still. Simple, right? Let's say John gets in a spaceship and goes for a spin, close to the speed of light. He flies around, does some space donuts, and goes back down to Earth to his twin brother, Jim. John is now technically younger than Jim. This is called time dilation. And yes, we've actually tested this with atomic clocks. This isn't just theory. Satellites actually have to correct for relativity. They're moving so fast, which actually slows their clocks down. But they're also farther from Earth's gravity, which makes their clocks run faster. Pretty weird, right? So yeah, if engineers weren't kind enough to care about this, our phone GPS would be wrong like all of the time. Then, all of a sudden, it's 1915. My bro Einstein turns it up a notch and says, hey, gravity doesn't just pull things. Massive objects like black holes and even Earth actually kind of bend the fabric of space-time. Kind of like dropping a bowling ball on a trampoline. Black holes kind of take this to another level. They're incredibly compact, collapsed stars with gravity so strong that not even light can escape. If you've ever seen Interstellar, you'll know what I'm talking about. When they go to Miller's planet, 1 hour is equivalent to 7 years on Earth. Because Miller's planet is extremely close to a massive black hole and moving insanely fast, space-time is stretched way more than on Earth. Hence, time moves slower. Black holes also have a weird effect on light too. When light tries to escape from a black hole, it's stretched and turns more red in color. This is known as gravitational redshift. Oh look, John and Jim are back, and they're taking the spaceship out for a ride. John decides, yeah, this is a great idea, and leaves the spaceship and goes into a black hole. Jim watches with his super sci-fi telescope, but all he sees is John frozen in place on the event horizon, otherwise known as the point of no return in a black hole. This isn't like a physical surface or anything, it's a boundary that once crossed, no signal can ever reach the outside universe again. John and Jim will never speak again. John appears to be stuck there forever. At least from Jim's point of view. A second of John's time could correspond to millions of years passing for Jim. So time kinda breaks. Or at least it stops behaving the way we expect. So, black holes don't just bend space, but time too. Yes. John and Jim are aging at different rates even though they're twins? Yes. But somehow, both of their perspectives are correct. Yes.